Already looks like we are almost good to go. So yeah, next up we have Terence from Prismatic Labs, who will talk about how Prysm plans to interop with other ETH1 clients. And I think he's here already.
Hi, yeah, can you hear me?
Hey, yes, I can.
Thank you for having me. It's great to be here. So let me share my screen. 1 second. Yeah, I'm super excited to be here. So can you see my screen all right? Are you able to?
I can. Yep, looks good.
And then you can hear me as well, right? Cool. Can I go?
Yep, the stage is yours.
Okay, thank you so much. So hi everyone, my name is Terence. I'm from Prismatic Labs. I'm most known for my work on Prysm, which Prysm is an E2 client. So in this talk, I will go through more on the client implementation side. What's our perspective on Rainism, the hackathon, which Proto Lambda is doing a great job hosting, and the upcoming merge. So let's get started. So agenda. So I will touch base on consensus on execution. Most importantly, the separation of concerns here. But I will skim through them rather quickly since the early presenters already did a really good job on covering them. So if you haven't checked out the previous presentations, I highly recommend you to do so. It's a recording on YouTube. And then for the second half, I will cover more client implementation detail. I will dive deeper into the code changes, some of the design decisions that we made. And my goal is to hope to attract more client implementers into this ecosystem, whether it's for Prismatic Labs, Simba Prime Lighthouse, TagCool, and the ETH1 stuff or the ETH2 stuff. There's so much to do, and the more people we can get, the better. So I read this article by Barnaby a couple of days ago, and there's this quote that caught my eye. It says that Ethereum today is what ETH2 developers are calling ETH1. The current proof of work chain that we all know and love. Ethereum tomorrow isn't ETH1 nor ETH2, it's just Ethereum, right? And I highly recommend you should check this piece out. It was a great read. So from this, I would try to refrain myself from saying ETH1 or ETH2. Instead, I would be using the proper terminologies, which is beacon chain becomes the consensus layer. It is responsible for the agreement of data, right? And beacon chain will be represented by what today is called the beacon node client. There are Prysm, there are Lighthouse, there are Nimbus, there are TagCool. And I'm sure most of you guys have had experience with them, whether it's for staking, whether it's just for playing around. And yeah. And then there's this current Ethereum chain, whether it's the execution layer. And then this is responsible for interpretation, it's responsible for transaction of the data. And this is represented by the pre-merge proof of work client. And that's like get and that the mine and so much more. So let's go through some graphic representations, right? So now we have essentially two chains and two chains that are going on at the same time, and both of them have consensus, right? Then you have your current Ethereum chain, which operate under proof of work consensus. It has its application network, whether gossiping, application block, and then you have your state tree, it manages receipt, account, balances, and stuff like that. Then on the other end of the universe, you have your beacon chain, which is operate under proof of stake consensus. And then this beacon chain is governed under validators, not the miners. And And the chain consists of what we call management data. It's governed by validators, right? You track validator balances, you track the latest slashing, and so that. And the network is gossiped via consensus objects. How much the validator balances has, what the validators are voting, whether the validators are performing poorly or nicely. And then you have your beacon chain state, which tracks the balance, the randomness, finality, and all the fun stuff, right? So there is a subtle link here that is the deposit contract. And because of the beacon chain itself cannot come to life, it needs some sort of bootstrap mechanism, right? So it's bootstrap, the stakers on the beacon chain is bootstrap using this deposit contract into the current Ethereum chain to deposit 32 ETH. So there's this very tiny subtle link here. So here's more graphical representations. And you can kind of think of like beacon chain, the consensus layer as a wrapper on top of the execution layer, which is the so-called current Ethereum chain. And so under this merge, right, the execution layer no longer needs proof of work because it can piggyback on the proof of stake consensus that beacon chain operates in, right? So it no longer needs the agreement on data. It needs the agreement on transaction ordering, right? So its focus becomes execution only. And that's like EVM, that's state size management, that's transaction ordering, that's the gossiping of the transaction data, right? So noted, you don't need to transaction a typical block anymore. You just need to transact transaction data. And you do realize in this model, I also added the data layer as well. And for the sake of time, I won't cover so much into like what the data layer consists, but the data layer is more for like data hungry applications for rollups and stuff like that. And then it's also connected onto the beacon chain. So the beacon chain essentially becomes this spine chain that governs through everything. So now we have two chains, right? Which means that there's essentially two pieces of software. And the hard question, right, is that how do they communicate with each other, right? How do they interrupt with each other, right? Like what's the communication protocol for that, right? So so far we have come up with a minimal viable protocols that we can provide to get them to interrupt. There's 4 essentially JSON RPC calls. There are assemble block, new block, set head, finalize block. I can go over them quickly in detail. So assemble block is when the consensus layer asks the execution layer to help me produce a block. And then where new block is consensus layer asking execution layer to process and verify this block. And the set head is essentially consensus layer telling the execution layer that, hey, this is a new head of the chain, because you don't need to run Fortress anymore. I can run Fortress myself, and this is a new head, so just follow it. And finalize block is essentially there's this nice finality property on the proof of stake. Now the execution layer could leverage that property. It tells the execution layer to say, hey, this is finalized block, and maybe everything before this finalized block that we no longer care. You can do some nice pruning and stuff. So very high level definition. We can go more into detail. And these definitions are also covered in the merge spec and the randomness spec that Proto put out earlier. So take a look at that as well. So I'm gonna take a little turn and start that more into client implementation details. And so the client I'm working on is Prysm, and it's one of the 4 to implementation. Our client is written in Go, and so written in Go, it has this natural interoperability with the current execution client, which I will go more into detail later. And that's our GitHub page. Give us a follow, give us a star, and yeah. we'll be really happy. So there is some design decisions that we made, and I will go through them one by one. So we use Protobuf and we use gRPC. So you may ask why Protobuf, why gRPC, right? And we get a lot, right? So we're a huge proponents of gRPC, Protobuf gRPC, because we love the compactness of the format, the low overhead, and then the strong typing, right? Bytes are bytes, integers are integers. And we love the ability to essentially generate schema via spec. And the spec is actually really useful for both servers and client. The spec could be forward and backward compatible changes that cover them really nicely. And it has better communication primitive, right? You have HTTP2 by default, you get bidirectional streaming, you get concurrent requests over a single connection and all that, right? And we also can support REST. We can support GraphQL using its function as well, right? And then the performance is probably slightly better, even for the smaller payload and stuff like that. So, the argument against Protobuf gRPC here is that REST does have the more simplicity, human readable format, stuff like that. The statelessness part is very nice, and it has more features to support existing infrastructure, such as like caches, reverse proxy, and all that stuff, and stuff like that. So, but the end of the day is that we can transcode gRPC to JSON very easily with a gateway, and that's what we're doing today. So we can support both, and this is purely a client implementation detail. Here's some code examples. I will go through like some code examples, and then I will let you see what it looks like in the Protobuf gRPC world, right? So this is the beacon block changes under the merge, and Proto showed that earlier as well. This is what's defined. It's Python. It's pretty readable, right? It's very readable actually, right? You get fields, and then you get the ordering, and then you get how many bytes are in the field. And this is what it looks like for Protobuf, right? It is readable as well, right? You get the fields, you get the ordering, you get how many byte size on the SSE for the SSE stuff, right? And so this was the execution payload, and that's one of the new field. It's essentially what the ETH1 block becomes. You translate the ETH1 block into the execution payload, and then the payload gets appended inside the beacon block body and stuff. So it's the last field, it's field 9. And here is the beacon state changes. So the beacon state changes has this new field. It's called latest execution payload header. And then the header consists of the current data executions block hash, parent hash, clone base, and all that fun stuff. But it's readable in Python, and it's also readable in under Protobuf. And then here we define the SSE size, so we know like when we marshal, when you hash true root, we can get the consistent data behind it. This is what it looks like, right? So so now the next question we have to answer is that, right, how do consensus and execution nodes start, right? So now there's probably two pieces of software that we have to consider. So you start your execution node, which is your current ETH1 node, like get, catalyst, nevermind, and more, right? So you launch a command, and the execution node has a RPC server, and I'm just using get as an example right now, and I use 8545 localhost. And now then you start your beacon node, which essentially has this proof of work node client that listens to 8545. And then you start your validated client. So there's three steps to it, and it's not pretty, right? Like, don't get me wrong, like this kind of sucks to have to like type this and launch this 3 times and stuff like that. So a cool hackathon idea that anyone wants to work on is essentially translate this into a more uniform front end stuff. So whether you can launch it with a script or launch it with a UI and stuff like that. And I think the community could really benefit that. So how do the interactions look like, right? So you can think of this like two distinct events, right? So there's two things that could happen. Either you're processing a block or you are producing a block, right? So to process a block is very simple. You get your typical beacon block from the P2P gossip, and then it goes to the networking service, and then it goes to the state transition service, right? And at the state transition service, you break that block apart, then you get this execution payload, which is consists of application data, and then you pass that into the ETH1 proof of work client service, and then you pass that to the get your FMI node, and then they will verify that and then tell you whether, hey, this is valid data, I can perform valid execution on top. Then they will return the status. Then you can safely confirm that, hey, my beacon block is correct. So that's on the processing side, right? And now there's another event. It's as a validator, you get to produce block, right? You get to propose block, and that's how you make your most money. So to propose a block, it's the same path, right? You essentially determine you're the proposer of a slot, then you ask your get node, be like, hey, I'm producing, can you give me some data to produce? And then get will return execution payload, and then you package that into the block, you pass it to the validator client, the validator client then signs off on the data, and then you broadcast to the entire network. So there's two paths, but it's pretty similar it's pretty similar in today's process, how we process and how we propose. The only difference is that we add this additional step that we have to check with the execution client. So I was actually surprised that the lines of changes, so the amount of changes were not so much, and it's pretty nice. So far, if you look at our branch, it's probably like 500 lines of changes. But keep in mind, this is not production level code, right? We're doing a proof of concept here. So this is preliminary. So the number of lines of code may increase later, right? But with that said, I do think the heavy hitting is on the ETH1 client side. They're doing more subtraction by addition. So respect and props to the ETH1 client for doing a lot of those work as well, right? So Prysm probably has a 25 package as of today. And then the only changes are in those packages. So probably 20% of the packages are getting changed. So here's just one of the main addition, right? So after you process the block, you check with this application execution client on the validity of the data. So you essentially you take the block, you look inside the body, you get the execution payload, and then you basically translate the payload from our protobuf data to JSON data, and then you insert that into the execution client. And the execution client will tell you whether the data is valid, and if it's valid, then you can process the block. Very simple, right? And then on the other side, to produce a block, you you essentially ask the execution client to give you the latest payload, and then you return the payload back to the beacon block, and the beacon block gets signed by the validator and gets broadcast over the network. So again, it's very simple. So here's a few screenshots that we did have the interruption running earlier. So I just cover a few I put up a few screenshots for fun. They're the same screenshots that Prolo posted earlier. This is just a Prysm beacon node inserting application execution data into the ETH1 node. And this is a view on the ETH1 node. It's producing block and importing new chain segment. And this is the validator client. Validator client are attesting the block and also proposing the block. Right. Now I'm gonna go through a few more slides of design decisions. So we use Bazel, and then we get this a lot, right? Why Bazel? And Prysm is a mono repo. So instead of using the default Go build system, our team relies on the Bazel build system to manage this mono repo structure, right? We love it because of its reproducible build. It has a sandbox environment, and the builds are pinned with proper dependencies, such as Go versions, right? And this would be guaranteed to have the same outcome, despite like different developers, users may have different machines stated, right? So some common issues that I've seen, right, that bugs introduced because of the environment is different than being shipped to users. There's just messy dependency management when dealing with a mono repo with multiple programming language, right? And Bazel is nice. It also has remote caching, and then it has advanced dependency analysis and stuff. So we have a Bazel Go Ethereum repo. It's a Bazel-friendly copy of Go Ethereum. It's nice because we do have Go bindings. We take advantage of using Go. We create Go bindings on top of JSON RPC. So we no longer need JSON RPC cars for the RPC codes that we need to do and stuff like that. So check out the report if you're interested. It's very cool. And here's just an example of when we call a sample block to, if we want to produce a execution block, and we can just literally dial the HTTP client. In this case is get Nethermind, and then we just call a sample block. That's it, plain and simple. We also use this SSC library. It's called Fast SSC. So a quick rewind, right? What is SSC? So SSC is a serialization format that's used in ETH2. It essentially conveys two standards. The first standard is encoding and decoding. So how do we decode ETH2 data such as beacon block and beacon state, right? We essentially want a string of bytes that can be sent over the network or stored in the database, and that string of bytes have to come to consensus with each other. Then the second one is materialization. So how do we find the hash of the data? And in this case, we don't say hash, we say the Merkle root of the data, right? So we use this FastSSC library. It's essentially generated code, so it's very fast. And if you're working on this SSC related fields, check out that repo, and it is very interesting, and there's a lot more work can be done there as well. So just to recap on the API, we have our own Ethereum API that's the protobuf spec that we implemented. It has more advanced features in terms of just like bidirectional streaming, and then it's a little bit more powerful. Then we have the standard ETH2 API, which we also comply as well. So and then the default endpoint on the beacon chain, on the beacon node is 3500. So if you're playing around with it, you're building a cool hackathon project with it, definitely use those. And the next one is Matrix, right? And Matrix is super useful in terms of debugging and then monitoring. And then we use Prometheus for scraping Matrix. Their default 8080 on the beacon node, 8081 on the Validator client. And then we use Grafana to visualize, to basically for visualization. And here's a cool one that our community member built, right? And then maybe a cool hackathon idea for this is that someone could combine the matrix for beacon node and also the execution node, combine them to the same place to visualize performance, to visualize like transaction related interesting fields and topics and stuff like that. And just another idea for our cool hackathon project. Then yes, I'm personally very excited to hopefully to have a merge testnet very soon. We're working towards that. I think there's some great value in understanding how the merge will work once we have a testnet with the community, and then people can interact with dApps, and then you can visualize the network performance and stuff like that. I think that will be very useful and very valuable as well. And getting towards the end, so to contribute, feel free to go on our Discord or check our GitHub open issues. We have a contribution guide as well. And not just for Prysm Prismatic Labs, right? Please do check out other E2 clients. They're not here today, but they are not here presenting today, but they also are doing amazing work, and they could use help as well. So check out TechCrew, Lighthouse, Nimbus, and Lodestar. There's definitely tons of work there, and they are also amazing. And yeah, and that's for me. Thank you for having me, and shout out to ETHGlobal for hosting such awesome event.
Great, thanks for all the insights. We have a couple of questions that I want to relay to you. So first of all, while your talk was going on, there was a lively discussion already going on in the chat with regards to execution responsibility. And basically, the overall question was like, why not implement the ETH1 execution functionality into the Beacon node software directly? The person who was asking this, yes, he already got a reply via the chat, but he wants to hear your opinion on this as well.
Right. I think there's two sides for this. So I think there's need to this short to mid term and there's long term, right? I think to mid to short term, having the separation of concerns is nice, given the timing constraint and stuff like that. And you also lower the risk, right? So you don't want to redevelop EVM, you don't want to redevelop transaction pool, you don't want to redo all those, right? It takes years of engineering research expertise of that, right? And then we want to leverage as much as possible. So having a separation of concerns is nice. So now the question is that how can we make the process better, right? Whether it's launching a unified front end to essentially to kind of make people think that we're actually not running multiple processes, but we are running multiple processes. So I think that's a really good hackathon-ish project to think of, and I think people should pursue that.
Then another question right here. Will the public testnet also interact with other non-Prysm clients, and any time frame for the testnet?
Yeah, so the goal for the testnet is to be multi-client-ish to start with. So there will be Lighthouse, they're doing great work. TechCrew, of course, they're the first one that's doing it, and Nimbus as well. So it will be there will definitely be multi-client, talking with multiple execution clients as well, right? So timeline, I think this week we'll be making a lot more progress. To be honest, we've probably made so much progress the past week than we have for the whole month. So I think we're close. I think next week and early next week with the leadership of Proto and stuff, we should be able to launch semi DevNet. And once that goes well, we can go full public.
And then lastly, a rather technical question. Why are you using Bazel instead of pure Go?
Oh, yeah, I thought I covered that. So long story short, we use Bazel because of the reproducible build, because of the mono repo-ish setup that we have, and also because of the remote and then the local caching and stuff like that. And I get that right. Bazel there's a little bit of learning curve and stuff like that, but once you get used to it, it's not too bad. It is super fun.
I think that's it in terms of question. Thank you so much for joining and sharing all those insights with us.